Oh, hey, y'all, welcome back. We're continuing to look at the products of fractions today. We have had some pretty cool days of practicing and understanding these skills around how we multiply when working with fractions and whole numbers, right? So, like 3 times 1/4, and what these things mean. And we've actually kind of looked at multiple processes. We kind of have different techniques, right? Like one technique, we've looked at this concept of how we can really just model what this looks like in order for us to understand what our product is, right? Model, define the product. That's one thing we could do. Um, we also have talked about this idea of how we do know that this is also a sense of repeated addition, right? We're talking about equal groups, and that is what repeated addition is. I guess really this should be like more like called equal groups. Groups equal. And then we've also really gone into this most recent one of like fraction sets. A fraction set, or that concept of fraction of, right? Thinking about that of thing. And today it's really thinking about like what do we do when we see each one so that we can make sense of helping us solve that. And that's exactly what we're going to get into today. So let's go ahead and start with this one. And I'm going to go ahead and just go with model for the product. So let's kind of move into that piece. So our first example today is 3 times 1/4. So when thinking about this process, again, one technique we've talked about is modeling. So I'm going to go ahead and model out what I have. This is telling me that I have 3 groups of 1/4. So I'm literally going to draw 3 groups. And once I've drawn my 3 groups, according to my fraction, each one is cut into fourths, right? That's what the denominator tells me. And then I have one of those fours shaded in. Now, to help me find the solution of this is like I'm putting these things together. So the reality is I'm just going to go ahead and take like this fourth. I'm going to bring it over here and shade it in, right? And then that allows me to know that actually that's gone. I just moved it over there. And then we're going to go ahead and take this fourth. And I'm going to put it over here as well. I'm just combining them so I can make sense of it. So now that's gone. And if we look at that, well, there's our solution. We can see that we have 3/4 here. We don't have anything here. This is a 0 and this is a 0. So 0 plus 0 plus 3/4 gets me the answer of 3/4, right? So that's that modeling technique. So this comes in really handy, I think, when you're dealing with a smaller number of units and you're also just thinking about like how you can condense them or put them together. Second example, all right, our second technique that we've been talking about is repeated addition. So again, let's take that to this and think about if I had something along the lines of 5 times 2/6, right? And the same idea. This is telling me that I have 5 groups of 2/6. So just like we did in the last example, is I could draw a bunch of models of 2/6, but the reality is I'm thinking in my head personally, I don't know if I want to draw 5 of these. And then B, like, is it really efficient to sit here and cut them all into sixes? Like, I just feel like I'm going to be here a while modeling. And modeling's great. Like, I highly encourage modeling. In fact, you don't make too many mistakes when you actually model. But in this case, I understand that really what that means is I can kind of, I don't know, what I like to call sometimes is that shortcut. Like I actually know that if I have a model, instead of like drawing out all the model, I just know that it's going to say 2/6. So I could think about the idea that I just know I have 5 groups of 2/6. So I'm just going to take 1, 2, 3, 4, and 5 of these. And now I'm just adding fractions. Well, are the denominators the same? Are they compatible? Yes. So it stays the same. And then I'm going to take my numerators 2, 4, 6, 8, 10. I see I have a top heavy fraction. So that just means I need to do 10 divided by 6, which would equal 1 and 4/6. And if you need to see that mathematically, 1/6 goes into 4. There's my remainder again, 1 whole, 4 left over, 6 is my denominator, right? So this tells me I have 1 and 4/6. Now, I could have done this as modeling as well, but again, I chose to use a repeated addition strategy, and that's fine. That's what we're doing as mathematicians. Like, what makes sense to do when we need to do it? So then, oh, actually, I guess we have 4 techniques. I didn't even really think about that because I'm going to come back here. And one thing we didn't really say in here is we also have just the multiply, then divide technique, which I think will come in handy in this next one, because if I go and think about another scenario, let's just say I'm given something like 38 times 1/9. Okay, so now I'm kind of in that place, right? Because I don't want to draw 39 boxes. And honestly, I don't want to cut them into ninths either. That's going to take a long time. Um, I could go repeated addition. I could. But that also means I'm taking 1/9 and I'm writing it 38 times, right? Like, I don't know how efficient that's going to be for me. So if we come back to that idea that what we do recognize is that the reality is I'm really taking these 38 models, and in each model, there is one shaded piece. So that actually means if I say 38 models times one piece in each model, I'm gonna have 38 pieces total. And we also know that my denominator is not changing. The size of this piece is never changing, so it's still at a 9. So this is like that multiplication technique where actually I can just multiply my whole number by the numerator and then my denominator stays the same, but I do have to convert, right? I do need to turn this into a mixed number. So I do have to think about this idea that I have 38 being divided by 9. I'm going to go ahead and put that into partial quotient. Let's see, what do I know? 9. Oh, 9 times 4 is 36 with a remainder of 2. So actually, when I have 38 times 1/9, I get 4 wholes, right? That's this right here. And then I have a mixed number. I have a leftover. I have 2 left over out of the 9. So this would be my answer, 4 and 2/9. And so you can see here that this process actually helps as well because, gosh, it would have been crazy to draw 39 models or excuse me, 38 models, or to write the fraction 1/9 38 times. So that really helps. Now, let's just dive into that final piece. And this is where things change. If you notice with the last 3 examples, we had a whole number first, right? 3 times 1/4, right? 3 groups of 1/4, 5 groups of 2/6, 38 groups of 1/9. But what also happens is we think about that associative property or that flip on it, that sometimes it's actually asking me of like, well, what is 3/5 of 10? So in this case, my fraction is first. And this is where things differ because mathematically speaking, it's actually telling me I have 3/5 groups of 10. And that's really confusing if you think about that, because how do I draw like, right? Like what? Like I have to draw like 10 holes and then I'm like dividing them into fit. Like it gets really confusing to think about how we've used these other techniques to solve a problem like this, because again, we're actually not cutting 1 into 3/5. We're actually taking our 10 things and we're figuring out what would happen if 3/5 of them were gone. And so this is that modeling technique where you're thinking about a fraction set. This is the new one, and this one's important, right? It's a good way to actually really understand what's happening here. So if I go into that process, right, the first thing I'm going to do is I'm going to model this as a set. I'm going to model it as an array because rows and columns are good friends of mine, right? It's a set. So if I have 10 things, let's see, maybe I'll organize them in a group of 1, 2, 3, 4, 5, and I'll do 2 groups of that, right? Again, if you look at that, and I like putting the rectangle around it. Oh, it looks like a Lego. That helps me out because really what this is saying is I have 5 columns and 2 rows, right? Because you can see that. Boop, 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 rows and columns, right? But at the same time, these are just my 10 items I'm looking at. And now I want to think about, well, I'm saying, for example, like whatever, I don't know, let's call these cookies. I have 10 cookies and 3/5 of them are I don't know, broken. How many, right? Like, how many cookies is that? Well, let's figure that out because it's saying I'm taking these 10 things and first I'm putting them into 5 groups. Oh, well, this is helpful because actually I have 5 columns. So if I just go here, 1, 2, 3, 4, and 5, you can see I actually had those 5 groups. I'm going to write it down here. Here's group 1, here's group 2, here's group 3, here's group 4, and here's group 5, right? See what I'm doing there? Here, I'll extend it a little bit. Now that that's occurred, we want to think about, well, if this was a fraction and it's supposed to be 3/5, and here's my 5 parts, well, 3/5 would be 1, 2, 3 pieces that are shaded in. So how many of those circles have I shaded in technically? And that would be 1, 2, 3, 4, 5, 6. So when I take 3/5 of 10, I actually end up with 6 items. So again, what was my scenario? I had 10 cookies and 3/5 of them broke. Well, that means I have 6 broken cookies. It means that actually I only have 4 cookies left over that aren't broken. So that's really the process of today is like, what are you doing when you're doing it? Like, what technique are you going to try out and make sense of so that you can have an accurate answer? Are you going to model it? Does that make sense with the numbers that you have? And I do think that modeling is such a great technique. So don't just be like, oh, I'll never model. Like, it helps to model when your numbers are smaller, fewer whole numbers, smaller fractions, whatever. Are you going to go with repeated addition? That's also a great way to have the answer because that's something we know how to do really well. So again, can you figure that out, moving that? Or is it that we are going to, I guess I should have been showing these, go ahead and do just that multiplication technique where I multiply my whole number by the numerator and then I'm just going to divide it by the denominator. That's going to get me the same answer as if I was to literally model everything out. Or is it that I recognize that this time the fraction is first, the whole number is second. So I'm drawing a model that actually represents the math I'm doing, and it gets me to a good, clear, accurate answer. So with all that being said, I'm going to leave you at that. Keep up the good work. Remember, as you have questions, always ask, right? Just being here watching a video doesn't mean that you have to figure it all out on yourself. So as questions come up, don't hesitate to ask, and we'll see you next time.